All right, ladies and gents, today's lesson is about multiplying radicals. The process for multiplying radicals is fairly straightforward, but sometimes you have to do lots of multiplying and lots of simplifying. And so we're going to do a few examples here on our notes. So if you're not at your notes yet, pause the video, get your notes out, go to where it says multiplying radicals, and we're going to be working from there. So here is the process for multiplying radicals. The numbers out front, the coefficients, get multiplied together. The numbers inside your radicals, the radicands, get multiplied together. So we'll make something like this. And once you're at this point, if this number in here, if you can simplify it more, then you go ahead and simplify it some more. And that's it. That's the process. But you just have to make sure you're multiplying the correct things together and making sure you're simplifying. So we'll show you a little example of how this works. So if you have 2/5, sorry, not 2/5, look, 2 root 5 and 7 root 6 multiplying again, the 2 and the 7 multiply together, and the 5 and the 3 multiply together to make 15. And so now we got 14 root 15. 15 does not simplify more because just 5 and 3, which neither of them have a pair, and so it just stays as root 15. Here's another example. If you do have root 15 and you're timesing by 3, you get root 45, which you can factor that. That becomes 9 and 5, and 9 has factors of 3 and 3. And so you can square root 3 times 3 to get the 3 outside, and you'll get 3 root 5. So let's do a couple of examples here. We got an example here with just numbers. Here, pretty straightforward. You do 9 times 12, which is going to get you 108. And that definitely can be factored out some, so we need to factor some things out. Actually, we could just factor out 9 and 12. 9 becomes 3 and 3. That's a pair. 12 becomes 4 and 3, and 4 is 2 and 2. So you got a pair of 2s, you got a pair of 3s. Those come outside, we got 3 times 2. And then inside there's just the 3 left over, and so that'll give us 6 root 3. So this is our first example. It didn't have coefficients, but if it had a number like 5 and 7 outside, you'd times those together out front, and they'd be out front with this 3 and 2. Let's try out this example, which does have a coefficient on one of them. So yeah, we're going to multiply this and this coefficient together. This coefficient out front is just 1. And so you got 1 times 2, you got a 2 out front. And then inside, you got 12 and 6, which gives you 72. And then you got x to the third and x, which is going to give you x to the fourth. And the inside of this definitely can be factored some more. 72 is 9 and 8. And 9 is just 3 and 3. 8 is 2, 2, and 2. Or 4 and 2, and then 2 and 2. So we got a pair of 3s, pair of 2s. We got 2 left over. X to the fourth is x squared and x squared, which is a pair. And so those go out as well. So we got a 3 coming out. We got a 2 coming out to join the 2 that's already there. And then we got x squared coming out. 3 times 2 times 2 is 12. Sorry, I forgot about the x part. The x squared comes out. And then this little 2 guy is left over all by himself. So he'll stay inside. We got 12x squared root 2 for multiplying those two together. Nice. So this is pretty straightforward, pretty simple. You multiply things in front, multiply things in the middle, inside, and then simplify the inside if you can. Well, you can also multiply radicals if there's distribution involved. Say we have the square root of 6 multiplied by this thing that has 2 terms in it, and it's in parentheses. You are going to distribute. So root 6 gets times by that, and root 6 gets times by that, which gives you 6 times root 3, 6 times root 12. 6 times 3 is 18, and 6 times 12 is 72. And then you're going to factor those, and that's what all this stuff is. So 18 is 9 times 2, and 9 is 3 times 3. 72 is 36 times 2, and 36 is 6 times 6. You didn't have to factor it exactly that way. There's multiple factorings you can do on both of these. But yeah, you can pull out a pair of 3's on the first, a pair of 6's on the second. So you get 3 root 2 and 6 root 2. And at that point, they actually have the same radicand, so you can put them together. So all together, you got a nice 9 root 2. So sometimes you start with something kind of complicated like this. It's got 3 different, it's got 2 terms and an extra factor there. And it simplifies to be just a single radical, which is pretty nice. So I want you to give that a shot. I will pause the video and see if you accomplish it. Go ahead and pause. Give it a shot. Alright, so you can distribute this root 2 to both of those. It doesn't times by the 5 or it doesn't times by the thing in front. So on the first one you got negative 5 root. 2 times 6 is 12. And on the second one, you're going to get root 20. 12 is 4 and 3, so the factors would be 2, 2, and 3. And 20 is 4 and 5, and 4 is 2 and 2. So you got a pair of 2's on both you pulled out front. So on the first one, you got negative 5 times 2, which gives you negative 10. And we got a 3 left over, so you got root 3. On the second one, you pull out the 2, factor of 2 in front, so you get 2. And the leftover part is 5. These have different radicands, and so they can't combine. And so our problem is done. Looks like this. So there's distribution. Sometimes you have something like this where there's two different terms in 2 different factors, and the way to do that is with double distribution, which looks like this ginormous mess. But let me draw my own arrows here. I'm gonna do some white out here. That was too much whiting out. That was still too much whiting out. Yeah, let me kind of show you the process here. So this term is going to get times by both of these. And that's what's happening here. So it's 2 root 3 times 3 root 4 and 6 root 6. 6 root 7, not 6 root 6. And then after you've done that, you're going to add this term times by both of these. So that's why it's plus here, negative 4 root 5 times 3 root 4, and negative 4 root 5 times 6 root 7. And that's the setup. That's how you get to this first ginormous step here. The rest of these steps is all simplifying, which doesn't look like it's doing a whole lot of simplifying, but it is. You go through, you simplify each of the parts, and you go down from there. And so let me show you with this. This kind of has some big numbers. Let's do one where it has a little bit smaller, a little bit more simplified, more simple things to work with. And so I'm going to take this one, and it times it by both of these. I'm going to write that over here on the left side. So I got 1 times 3, which is going to give me 3. And then I got 1 times root 3. So it's going to be plus 1 root 3, which is just root 3. And then I'm going to switch colors here. I got root 3n, and it's timesing by both of these. Root 3n times 3 is going to be 3 root 3n. And then root 3n times root 3 is going to give me root 9n, because the 3 and the 3 times together to make 9. So that's my first line here. Looking a little bit less complicated than the other one. But the rest of this is trying to simplify what we have. 3 is already simplified. Root 3 is already simplified. This one here, our only factors are 3 and n. So that is simplified. So that one's still the same. This one here, you can simplify some more. The 9 can be factored to get a pair of 3's. The n doesn't have any factors other than just n and 1. So it stays, but we can take a 3 out front. So we got 3 root n here. Our first one, the one before, was 3 root 3n, because it's just the same. Then we got root 3, and we got 3. These are all being added together. And now that I'm at this point, I need to see if there's any common factors. We got if we got any like terms, we got root n, root 3n, root 3, and then no root. These all have different radicands, and so it is done. There's no more combining that can happen. That's the whole expression. So there you go. We got double distribution, we got single distribution, and then at the beginning we learned that you multiply the things inside the radicals together and the things in front of the radicals times together, and that's how you multiply two radicals. So on your assignment, you have a mix of these. You got some simpler ones, some variableness. You got some where you guys do some distribution. And you got some where you gotta do double distribution. Just realize when you do your double distribution, distribute and simplify, and then chances are a lot of things won't combine. Maybe you will. Maybe you'll have something on the end that simplifies nicely, and it will combine with this. But sometimes it doesn't, just like this. So there you go. Good luck. May the force be with you.